Section 7.6, example 4, using Gaussian elimination to solve a system of equations. Use Gaussian elimination to solve the given 2x2 system of equations. All right, I kind of feel like we're a little bit more used to it now, so let's go ahead and jump into our system of equations. So grab this system, put it into a matrix by our rows being each equation, the first column being our x column, second column being our y column, and in this case, our third column being our constants. So for each equation, let's start with the first one, 2, 1, 1. Here we have 4, 2, and 6. So there isn't a nice way to start off just yet. So what we're going to do is let's start by, well, just dividing. There isn't one that makes it better. So here we're going to have to divide by 2. We'll have 1 half, 1 half here. For this equation, we would have to divide by 4, 1/4, 1 half, 1 or 3 halves. Yeah, something like that. So we're not, like, it's not going to be a pretty picture, so might as well just leave it as is. Let's multiply. Again, our goal for these are going to be 1, 0, 0, 1, and then with our constants on the side. So here, starting off with the first one, we have 2. Let's divide it by 2, so that way that first one gets turned into a 1, so we have a 1 where we need it. So 1 half times row 1 for the new row 1. And now you don't have to do the work on the side if it's still a little confusing. We could still do work on the side like we did for the previous problem, but you could also get into the habit of just doing the work in your head. So 2 divided by 2 is 1. Then 1 divided by 2 is 1 half. And again, 1 divided by 2 or multiplied by 1 half is also 1 half. Equation 2, we're not manipulating at all, so we could just copy it. All right, so we have a 1 where we need it here. This doesn't look like it's going to be a pretty solution, but we have a 1 where we need it here. Let's get the 0 next. So in order to get the 0, we have to multiply by the opposite of what we're trying to eliminate. Opposite of what we're trying to eliminate here is 4, so -4. So -1/4 is what, oh, wrong one. -4 is what we're multiplying to row 1, adding that to row 2 for the new row 2. Again, here the reason why we're updating row 2 is because row 1 already has a 1 where we need it. So we're trying to get the others to 0. So we're trying to get a 0 right there. So doing that in our head, or let's start with writing row 1 down. So 1, 1 half, 1 half. And now we do the work. So -4 times row 1 plus row 2. So 1 times -4 is -4 plus 4 is going to be 0. 1 time, or here, 1 times 1 half, or 1 half times -4 is going to be a -2. -2 plus 2 is also going to be 0. Ooh, I like these odds already. And again, here, -4 times 1 half is going to be -2. -2 plus 6 is a -4. Let's take a pause really quick, because if we were to turn this augmented matrix into our system of equations, what we would have so far is equation 1 is going to be x plus 1 half y is equal to 1 half. And then we have 0 is equal to -4. This bottom part is the part that's concerning, because what we have there is 0 is equal to -4. 0 will never equal -4. So here we would have no solution, or we could call this inconsistent. There's a couple of different things that we could call this, but in our case, we're just going to say no solution. So there is no solution to this system of equations. And that's it. If you have any questions, please feel free to ask. Otherwise, bye.